Hey everyone, this is Ryan from the homesteadconsultant.com. Today I'm going to do the long promised full overview of this outdoor off-grid bathroom system that I've installed. I'm going to cover every last bit of it in detail, so this video is going to be a little bit long, but I will start with a rundown of what we're doing so that you can see all of that before I get into the nitty-gritty on why I chose different things and how things were assembled. So I'm going to give a brief overview of how this whole system works before I give the in-depth view of what I chose, how I chose to put it together and all that. So what we've got is a composting toilet system on the left here and a heated off-grid shower system on the right. On the top, I've got solar panels as the roof, and I have those feeding a battery, which then powers a light inside, as well as a pump and a couple of other things as well. So I will show you those systems quick. Inside, you can see the toilet, and I'll explain more about that later and how and why that works. Over here, you can see we've got the solar wiring and equipment. So we've got the battery there that runs everything. And then up here, you'll see when I walk in, got a light bulb that turns on. And then back here, we have our storage tank, our pump, our gas cylinder for propane. And then inside the shower, we've got our water heater and shower system. So that is the system in a nutshell, and I'll start going over all the various different components of it and why I chose to do things the way I chose to do them. So first of all, a lot of people have had questions about our toilet system and how that works. Now, what we will eventually have, they still are yet in the mail to get to us, but we'll have composting bags. So those bags will go inside of this 5-gallon bucket, fold nicely over the sides, and the bags will then, when you do your business, you throw wood chips on top, or I should say, those are actually more like sawdust on top. And because of the high carbon in the sawdust, it bonds with the nitrogen and ammonia in your waste, and it keeps it from smelling, which, it seems odd, this whole setup, but it does a really, really good job of not smelling at all, and certainly not smelling like an outhouse. Now, this bucket system, there's a couple of things I did here. You can see these little rails. That keeps the bucket right where it's supposed to be. And then I set it up so that back piece right there stops it exactly where it's supposed to stop. So when I slide it in, it stops exactly where it's supposed to. And you can see basically it fills that hole exactly. There are a couple of things I need to do on this hole. One is I need to round off the edges. I may router it or sand it or something. And then two is this needs to be painted. Obviously, if somebody isn't very careful, they could basically get it on the wood and then the wood will soak it in, and we don't want that. So this will be cleaned up a little bit, painted, and look a little bit nicer, but it will feel mostly like using a regular toilet without the flush option. And then you have to throw sawdust in when you're done. So that is how the toilet works. Once that bucket gets about 3/4 full, because you don't want to handle it when it's truly full, once it's about 3/4 full, we're going to come over to our barrel here, and I've actually cut the top and bottom off of this barrel. So you'll throw the bag and waste in there, and that'll sit there for years. So once you, even if we had a workshop and a lot of people used it and it was piled up a little ways, that'll just basically break down and go back into the soil. We don't have any plants for foraging or anything else in this area, so that just gets to sit for several years and be left entirely alone. We don't have to deal with that right now. The next component in the system is our solar panels. So these are a type of solar panel that I'm getting for $10 a piece. So it is actually cheaper to make the roof out of solar panels than it would be to put an actual roof on here, given that this roof ended up costing me $30. And these solar panels have some oddities. You can't mount them on a typical roof because they're an odd fiberglass frame that generally just sits flat on a flat roof. So what I did is I mounted them to 2x4s and then mounted the 2x4s as my roofing system. And that was pretty much it. It was that simple. These panels are the SunPower. You can probably pause and get that model number if you want to. I can get them locally here in Middle Tennessee, and I've heard of other people getting them elsewhere, but I'm not sure where, so you might be able to look those up and figure that out. So those solar panels, you can do solar panels in series or parallel. In this case, I want them in parallel because these are 56 volt panels, and that's about as high of voltage as I want. If I put them in parallel, or I'm sorry, in series, then I would get about 160 volts, which is not what I want. So I've put them in parallel to here, and I know this isn't the best connection. I'm aware. Leave me alone about it. I'll fix it later, but it's not causing any problems because of the amount of amperage we're using. And so I basically tie these panels together in parallel instead of series, and then they go into our breaker, which will trip if we're using more amperage than this buck converter is supposed to. So this is, I believe, a 30 amp breaker, and so if we end up using more than the I think it's about 250 watts that this buck converter can handle, then I know something's wrong, which will trip this breaker. It's also there if I need to service it. I'm not going to be flipping it a whole bunch. Breakers are not really intended as a power switch, but I have it there in case I need to service things on this side of the system. And if I need to service things on the other side of the system, I can just go up to where the panels connect and pull those MC4 connectors apart. So that is how the panels are run. So at this point, they're 56 volts. And 56 volts here still. This buck converter is able to run up to, I believe it's somewhere in the range of 90 volts down to 45 volts. So that 54 volts is a good middle ground there. And then it converts out to 13.8 volts, which is a very specific voltage that I want to use. You can get 12 volt buck converters very easily, but I don't like 12 volt buck converters. And the reason I don't like those is they put out an actual 12 volts, whereas my battery, most lead acid batteries are going to be a 12 volt nominal voltage, but they want to charge it closer to 14 volts, and they will float at 13.8. So this 13.8 volt buck converter will basically charge this battery pretty much perfectly and never overcharge it. So that's why I'm setting this up the way that I am, is because with these panels, if I run them in parallel, then the voltage coming in at 56 volts is perfect for this buck converter. Then this buck converter outputs at about I think it's about 250 watts up to the system, which then charges the battery, and then the battery and all of the other wires and things, all the wires for everything is connected together at this one place. So this wire goes to the light that's behind me. This wire goes to the cigarette lighter adapter, which then I can adapt down to 5 volts for, that's USB, so I can charge anything USB, like a flashlight, a cell phone, anything that charges on USB, I can charge off of the system, which is going to charge off of this battery. I can charge my phone many, many times off of this one $30 battery from Walmart. So anyways, all those 12 volt wires tie into this one single location, including the ones that go to the battery here. So there's two more systems that run off of the 12 volt, and that is the lighting. So this may look like a 120 volt light bulb, but it's not. It's a 12 volt DC light bulb, and I've got a line running to up here. I want to clean this up a little bit, but it is what it is for now. I've got a line running to a PRI, or a motion sensor. It's going to be mounted a little nicer here. But as I walk into the bathroom side or the toilet side, or if I walk into the shower side, that motion sensor is able to pick up my motion in that area. And inside the motion sensor is actually You've got potentiometers, so you can tell it how long to stay on, how sensitive to be, things like that. So that motion sensor then turns the light on when it senses motion, and I have the light set to stay on for about 5 minutes. One thing that people might ask about or wonder about is why I've got so much wattage coming in when I can't use it. So these panels are 327 watts a piece. And that means that when I run them in parallel like this, if they're outputting at 100%, that means we're somewhere actually relatively close to 1,000 watts, which my buck converter can't even come close to handling. Well, that's actually okay, assuming that your voltage is not too high coming into a device. You can have more amperage. So this is something you need to understand Ohm's law and electrical for. So if that's not something that you're versed in, ignore this part and don't try to do something you shouldn't. But if I'm running more wattage into a device than it can handle, so that would be more amperage, but my voltage is within the spec of the device will actually be fine. And I can explain this or analogize this to a vacuum cleaner that you plug into your wall. The amount of power that your wall socket can put out is actually more than the vacuum cleaner can handle, but the vacuum cleaner only uses what it needs. So as long as my voltage is within spec going into here, I can have more wattage on this side and then it just doesn't get used. Now you might wonder why I would want to do that. Let me step outside and explain it. One reason is that we've actually got trees in the way for a good part of the day. And so if this is getting some sunlight, but not enough sunlight, I still have a decent amount of wattage going to that battery. So let's say it's getting 20%, which would be 200 watts. That would still be charging that battery great. And most of the time I don't even need those 200 watts. So maybe it's getting 10% because the sun's behind trees, but there's enough ambient light that it's just hitting these panels. It's going to be charging things at 100 watts. So no matter what, as long as the sun's out, even on a cloudy day, I'm going to be charging my battery and keeping things topped off. So that extra wattage doesn't hurt anything, but it makes sure that no matter what's going on, if I've got a cloudy day like today for several days in a row, I won't have any issues because that battery will be constantly being topped off. And it's so much more power than I would need that it should be fine no matter what. So anytime I need it, I'll have more power than I actually need. Another reason is that I just have 3 panels, and that's what worked really well for the size of roof I needed. And so it was cheaper than putting roofing on, and it wasn't worth worrying about the fact that I was putting in way more panels than my system actually needed. So hopefully that makes sense for people, how this works and what's going on there, and why I'm running so much more wattage than my system from here on can actually handle. So finally, the last thing that is hooked up in this junction location is the pump. So that comes here, goes outside. I've got a drip loop outside so the water doesn't get inside through the hole, and I'll show you that outside. This is the pump out here. You can see right there, my wires, the drip loop needs some work. The drip loop needs to go like this, so if any water gets on this, it'll run down and drip here instead of going inside. So I'll put a better drip loop in there. I'll probably put some type of grommet or caulking or something in here to fill that hole, but that's what it should look like, is a drip loop like this before it goes in. This pump is a 45 PSI pump, and it takes about 4 amps to run it. It's actually a little bit more powerful than I need, so I'm going to have to come up with a solution to basically slow it down a little bit so that it's not pumping quite as much water up and through as it currently is. And the reason I need that is it's pumping water so fast that the water heater can't actually keep up with it. So I'm going to have to slow that down a little bit. Another piece of the system here is this 55-gallon drum. Our water system comes out at about 1 to 1.5 gallons per minute, which means you would have 55 minutes of shower before this barrel is empty. And the way that I plan on filling this, which I have not set up yet, is I'm going to put a gutter system underneath here, then a downspout, and at the very top I'm going to put a downspout diverter that has one leg that comes off and goes in right there. And so that should keep this barrel consistently topped off. I don't expect people to be taking extremely long showers in this system, so that should be more than enough. And plus, in Tennessee, we get quite a bit of rain. Another item of note is tie downs. So because this building's kind of tall and flat and we get some decent winds, I wanted to put tie downs in. So I put a T-post all the way in, and then I'm using this U-clamp. It's going, there's a knob back here like T-posts have. So that's held really tight, connected to, and then I connected a turnbuckle to that. And then I have a very strong connection right here to the floor joists for the whole bathroom system. So that is essentially pulling this whole system down. And I've got one on the front and one on the back because it's fairly skinny, but also fairly long. So we've got 4 feet across here, but 8 feet across here. So I've put a tie down here as well. I know that I could get stronger tie downs, but these I think will do the trick for me in my given circumstance. And it's a lot better than not having anything. And this system is actually proven to be quite stable as it is, but I wanted to do that basically as just some added support and connection for the system. The next part here that I wanted to cover is the shower and how this is all working. I've used picket, so this is a treated picket fence, to use something that should stay fairly protected. I've put pavers here so you can walk in and out on those pavers. I will likely dig this out a little bit and put some more pavers, and those might even go around and connect over here, so we've got kind of a loop of pavers for people to walk on. Inside, again, I've used these pickets and I doubled them over, so I put one here and then one on top and so on, and that is so that we have a nice visual block from the toilet side, so you really can't see up and over that either direction. And you've got a really nice private bathroom area in here. One thing I do want to do is put some type of sealant, especially on the floor, but also on the walls, because I really don't want people having to stand directly on treated lumber. I'd prefer that to be painted or treated in some way. This is the water heater, and it's currently battery powered, so it uses 2 D cells. And the only thing it uses those for is for the igniter. So those will last a very long time. In fact, probably the general shelf life of those batteries will come to an end before the actual use of the voltage in the batteries will, because it uses very little voltage, very little amperage, and those batteries keep running. So this is the line in from the pump, and then this is our line out to the shower. So you only have one water line in, and you adjust the heat with a combination of this knob to change how hot it is, as well as this knob to change the flow rate of the water. In our case, we actually need to turn the flow rate down a bit to keep the water at a temperature that's appropriate. So I can show you how this turns on. Basically, there's always pressure to here, and then you just flip this switch, and then that runs the water. And also, you may have heard the clicking on this system, and you can see the flame inside of that little view location where that's running. So right now you can see it's at basically 90 degrees, and that's because I have the water turned to the full speed. If I turn that down, you'll see that temperature go up. So as you can see, based on the flow rate, it will change the water temperature. I've turned the flow rate back up, and you can see that water temperature dropping. So these 2 knobs give us some ability to control that. Now this top vent, you do need to be careful not to touch that. That will get very hot. And if you're wondering, here is the brand name. Here's the model information. If I had to do this again, I would choose the higher gallons per minute water flow. This one's actually at basically half a gallon per minute active flow to fully heat it properly. And so that's where I was saying I actually need to turn this pump down a little bit to get the flow correct. One additional thing I'll say about the electrical is that with the electrical system after the buck converter being 12 volts, so like this light and the PRI, or the sensor here, they're all running on 12 volts, and 12 volts is a very safe voltage for humans. The resistance in our body is too high for that really to shock us, with the exception of maybe if you stuck your tongue on a 12-volt battery. But I wouldn't suggest that. So that's a little bit of an aside. I've got a couple more things to finish off here. Right now you can see I've got a bungee that is basically my door closer. I'm planning on getting something like a spring system, like a screen door would have, and that would attach closer to here and there, which this bungee could as well. This was more of a temporary fix just to keep the door closed on most for now until we can get that spring system installed, but it's functional as is. So finally, I'll talk a bit about the framing and how I set all that up. Basically, I made a flat surface where I could put, I used 2x6s on as the floor joists, and I had those spaced at 16 inches on center inside. And so those are run in such a way that basically I was able to set them on the blocks here and start fastening them together and actually build the floor before I did anything else. And so you can see what I've done is I've taken 8-foot lumber. So this is 8-foot deck tread, or 5/4 deck decking boards. And I cut those in half. So they're 4 feet. So everything I've done, I've used dimensional lumber on, and I've gotten it in common sizes so that it's inexpensive. So these are at 4 feet. I just cut them in half at 4 feet and then ran them across the joists that run this way, back and forth. And so I built the floor first, made sure it was all square, and then I started putting the walls up. So basically I created these corner pieces by screwing a couple of 2x4s together, and I used all 2x4s inside. So those 2x4s got screwed together and then stood up straight, and then I put cross bracing like these across everywhere and basically built my frame. I built it really simple. It's not like stud walls or anything else. It's much simpler than that because it wasn't really needed, and I've got enough reinforcement elsewhere. So all of that then got connected to the base. I've got my cross braces and then, or my upper braces, and then the upper braces that I have is in the lower spots and things. As I started to connect the sheet goods here, so this siding that I'm getting, I was able, that basically adds the stability. So the siding itself has screws, and I used staples as well, 1/4-inch pneumatic staples to put this up. And that basically, as I did that, I made sure that the whole frame that I had put up already was square as I was doing that. So I was able to square it and plumb it as I was putting everything together. So I used these sheet goods, which are, I think they're $21 at Lowe's, and it's intended as siding. We will paint it once more because I don't really trust the priming to last very long, but we'll paint it once more eventually. And then what I did once I got all that in, and I got all these other brackets in, and then I started putting these pickets on. So I went around and installed all the pickets. The door actually came later, so that wasn't there initially. Initially, I just had some angle bracing in to keep things in place, and I finished installing all the pickets here and inside the shower. And then I had these uprights, and I wanted enough slant on my roof, so I made the height what I wanted it. I don't remember the exact amount, but I just basically brought the height up to where I wanted it, built these 2x4s around, and then I put 2x4 all the way across. I believe this was a 2x10, and another 2x10 up there. And then I mounted the panels to those 2x10s. So the 2x10s are fastened all the way across, and there's quite a bit of bracing. So we've got a 2x8 below it right here that's braced there, and this whole system is attached. So I've got quite a bit of attachments through the system. And then these 2x4s that are attached to the panels basically function as bracketing and mounting hardware to attach to these 2x4x10s that run across the top. And then finally, people have asked about the panels here. What I'll show a picture of this, but what I've done is I've actually taken foil HVAC tape, which is intended for can handle direct sun, and I've put it between these gaps on the top side of the panels. So I've overlapped just a tiny bit of the photovoltaic parts of the panels so that I could put that tape onto glass on one side. And then I ran two pieces together, made sure that was well adhered, and that realistically should last for many, many years and do just fine. So that's it for this build. I think that's about everything I can think of to explain how everything works. If you have any further questions, go ahead and leave those in the comments. I'd be happy to answer them. About 98% of those who watch my videos don't actually subscribe, and you're watching the whole thing, so why not subscribe? I'm not going to put out a whole bunch of junk videos that force you to watch things or give you a bunch of notifications. You're only going to get notifications for actually interesting, useful information that I'm putting out, and I don't put it out all that often. So please like and subscribe so that you can see more of the content I'm putting out, and I'd love to connect with you more. If you have questions or have anything else that you need, you can find my information on the homesteadconsultant.com.